Let me introduce myself. I'm Charles Fendt. I will be here with you for the next 30 minutes to make an introduction to the technology Mioty in the context from smart metering. So this is a webinar in English today. We are part of a series about the different radio technology used for smart metering. As I said, today is Mioty. You can keep in touch if you are also interested in other technology, and we will have other webinar online for other technology which are coming. So let's start. Today we are talking about Mioty. Let us start with a simple question. What is Mioty? Mioty is a radio technology co-developed between Fraunhofer Institute in Germany and Metering. It's a standard. You can find it as an ETSI standard online. It's a number 103/357. We are talking about low power wide area network. So if you know LoRa, we are addressing the same use cases. We are using the ESM band, free to use, like LoRa, mostly 868, 915, or 434 megahertz. And this is a technology designed for private networks. So the idea is that you are the operator of your network. You don't rely on the network from an LTE provider. So you have every card in your hands, and you can really operate your own network in this ESM free-to-use band to operate your own devices in your system. If you have a look, we are talking about a technology which is, I will say, with a low data rate. If you have application like video or something like that, it's not the technology for you. If you have some sensors or meters in your city, in your in the campus or in the building, it's a technology what you need to transmit 100, 200 bytes, perhaps less, only 10. With distance which can goes up to 10, 15 kilometer, with normally battery powered, because we are very low power. And so if you know competitors like LoRaWAN, Sigfox, Mioty is really an alternative for this technology. As I said, you have different mechanism for such network. You have standardized or proprietary. Typically, LoRaWAN is a proprietary technology because it's a Semtech technology, and you need some kind of code stack or silicon chip from Semtech to operate LoRa. You have the difference between public and private network. So you rely on an existing infrastructure, operate from a third party, or you have your own infrastructure. And with Mioty, we are here. We have something standardized on a private network, which is an on-premise installation. So you have everything in your hand. How does Mioty work? You must understand that Mioty comes with brand new idea and paradigm. If you have a look in existing technology, if you want to transmit a frame, if you want to transmit data, you open a radio channel, you send in this radio channel your frame, your information. And if you have an interference, if you have a loss of some time, a time slot is not there, at the end, you are losing your data. The idea from Mioty is to split the information and to spread this information through different channels. We are using this telegram splitting and frequency hopping technology to split the information and send it through different channels, and we can reconstruct the information on the other side. And the benefits of Mioty is we have some kind of reconstruction. This means that if you are losing up to 50% of your data over the year, if 50% of your bursts are lost, you will be able to receive your data and to understand what was sent in the year. So at the end, you have really something which is robust. You have a very high range, and you have something which is really scalable because you just send small bursts spread over different frequency in your band. At the end, you can expect, I've here the figure from 3.5 million messages per day. We are talking about 65,000 messages per hour per channel. So really, you can scale, you can spread a lot of nodes in your network, including nodes which are quite far away from your gateway location, and you can operate your own network with less gateway and have the full power of the system. So at the end, on top of this radio technology, so on this physical layer, the Mioty standards comes with an offer, which is a MAC layer, so more or less a transport layer based on this radio technology, but this MAC layer is optional. So if you need to integrate this technology in your own sensor, you can choose to use this MAC layer and to have the different benefits of this technology in terms of security, encryption, privacy. But you can also reuse your own system and your own encoding, which means that you can just replace the physical layer between the node and the gateway, replace it with Mioty, get the full benefit of the robustness and the scalability of the Mioty technology without any change on your infrastructure, only on your gateway to receive the frame. And this is really a big benefit of this technology. If you come with something which is new, where you don't have any existing MAC layer, you can use also this, I will say, built-in MAC layer, which provides you a lot of security feature, which will be the security standard from tomorrow. Something which is also incredible. You have already no way to know who sent the data you can receive. You must really use the network key and verify the digital signature of the frame to know who has sent the frame, and you have really a complete anonymization of your data. And also someone who wants to sniff what is in the air and try to understand who is sending what without decrypting it. You cannot make a mapping. This frame comes from this device. You have also the non-repudiation because of this signature on each frame, and you can really rely on the information. This message is coming from this device. So really state-of-the-art security. If you are using this, today the focus is metering. This embedded MAC layer is not used, or mostly not used for metering, because there is a OMS standard, and in the OMS standard, you have the possibility to just replace the physical layer to use this splitting mode and then use your existing OMS stack, encoding, key handling, and so on, totally transparently. This will be part of another webinar if you are interested in it. It is everything which is coming with the OMS Gen 5. So at the end, robust technology, highly secure, scalable, and flexible for your application. The benefit from this technology, I have already mentioned some benefits. Of course, the range, we are talking about 15 kilometer. We have installation with meter in a cellar or in a pit more than 10 kilometers away in a city from the base station. So really a long range, ultra low power. I will take an example after this slide. High scalability, high reliability, and mobility also. You can also use this technology for tracking, for example, bus in a city or something like that, because you can also operate this technology up to 120 kilometers per hour. This is, I will say, the technology, but what are the benefits for you if you want to use it? As I said, it is a private network technology, so you are relying on your own network. You don't rely on any kind of brand bond provider which want to cut off 2G or 3G to make a better rollout in 5G or something like that, and then you need to change some device in the field. You can really operate your own device with your own constraint worldwide in the ESM spectrum. The flexibility of the hardware is also something very important. You don't rely on the hardware from one specific company. You can use your own stack to modify your existing nodes to make them Mioty compliant without changing the electronic or the chip you are using, just by upgrading the firmware of your device. The cost efficiency is something which will be seen a little bit later in this webinar. Because of the range and the reliability of the technology, you need less infrastructure, and of course, less gateway is always a benefit in the deployment scenario you can achieve. Here I want to show you one example of a product from Deal Metering. This is a clip-on for water meter, what we already had, and we added the Mioty technology in it. So once again, no change on the hardware. The product is already in our portfolio since years, and we just make a firmware update to introduce a new long-range mode based on Mioty to transport our OMS data. So we keep the OMS stack for the application layers and parts, and we just replace the transport, the physical layer, between the clip-on and the gateway. In this specific device, we have one AA cell. We are keeping the wireless M-Bus, so the MS-V4 technology, with 12 seconds interval to ensure mobile readings, so walk-by, drive-by. We have hourly value of a Mioty. We have a range measured in a city from 11 kilometers, 11 kilometers. And we have 12 years battery lifetime with this configuration, with one AS cell, once again. So really something very, very efficient, and with a possibility to retrofit this new technology in existing product and to offer with it new experience and new use cases for your customer, or our customer in this case. it was shown in this example. Mioty is a standard, very flexible. Yes, of course, you have this ETSI standard now in version 2, and you can use it as standalone technology. This is typically the example from sensor, and there is now plenty of sensors using Mioty to make temperature monitoring, monitoring of air quality, or to trigger light in the city or whatever. But you have also the flexibility to reuse your existing application layer. There is already system working with IO-Link. You have system with the OMS, normalized with the OMS Gen 5. I didn't mention it at the beginning. I will try to take the time to answer the question at the end of the webinar, but feel free to put your question in the chat so that we don't forget the different question. I have one point more to address, and then we can answer the question. So with Mioty, you really have the flexibility to reuse your technology without changing the full stack. How do we compare Mioty with the other technology? There is other technology. I've already mentioned LoRa, Sigfox, narrowband IoT. The problem is that you have always to make compromise. With Sigfox, you have the issue that you don't have big payloads. You have a problem of power efficiency with narrowband IoT. LoRa is not really a standard, but more proprietary solution from Semtech and so on. And with Mioty, we have really a solution without any compromise. You can really operate it in the way you want to have, and you can transport 10 bytes or 250 with the same technology, the same reliability. And it makes really a big difference. In comparison, we have here a direct field test to compare LoRaWAN with Mioty. The reliability of Mioty is really something which makes also the difference. If you install meters, your meters are not installed, I will say, in outdoor, in a small area where you have a good reception quality. It's more or less always in a pit, in a cellar. You have difficulty to achieve your radio communication with the base station. But because of the Mioty technology and the way we transfer the data and the possibility to have up to 50% packet lost on the small burst what we send, we can achieve really big installation without a multiplication of the base station to get really nodes near every location of your base station. To compare, if you have a look in the wireless M-bus in T mode or C mode, you have a small range. We are talking about 300, 400 meters reception range in a city. If you have a look for LoRaWAN or Sigfox, you see a big difference. Yes, of course. But with Mioty, there is no comparison anymore. And this is why, at the end, when you look in the communication for the LoRaWAN, for example, you see some kind of figure which show you in a city to address 40,000 nodes, you have 600 gateways. So one gateway every 70 nodes per gateway to get a really good system. Sometimes it's a little bit more, sometimes it's a little bit less, but at the end, we are talking about 100, 200 nodes per gateway. We have installation in the field with 7,000 nodes per gateway, with 10,000 nodes per gateway. And it's really not an issue anymore with Mioty. So the scalability of your system is completely different. And this is something what you get directly if you are calculating your total cost of ownership. The amount of gateway you need has no comparison. And here, at the customer from us, 30,000 meters, you have not the 50% of your location what you need. And when you want to scale up and add 60,000 sensor, we didn't add any gateway. And with the 70 gateway, we can address 90,000 meters in sensors. And of course, this has a direct impact of the total cost of ownership of your system and the maintenance you need to spend to maintain the system. So Mioty, new technology with, of course, the benefit of the development of the technology from the last years. It's new, but for sure will be big in the future. So this was my presentation. I've seen that there is some question in the chat. Meeting the read stop, put delete meter, privacy policy. For the battery part, up to now, the technology is not done for battery receiver in the field. There is coming product with solar installation and battery, but as far as I know, there is no gateway with Mioty and battery. But I know that there will be products this year with a solar solution to be able to deploy base station also where there are no 220 volt or 110. The problem is also a problem of size of your system. For such a use case, there is alternative. You can install some kind of repeater, which will resend the Mioty signal so that you can extend your range for some part of your town, and you can have a repeater which work with battery with a battery driven. On the other side, if you need a third of your installation location, normally you can also choose the location to get the external power supply you need. But it is on the roadmap. If there is no question, I think that we will close the webinar for today. Feel free to keep in touch with us. As I said, there is a further webinar planned to dive in a little bit deeper in the OMS Gen 5, which is also based on Mioty, and for sure other webinar which will come. Thank you very much for your time for today. I hope that you've learned some information. Have a nice day, and perhaps we can see us in another webinar. Thank you very much.